Now we're going to be simplifying radicals. And to do that, we have a couple of properties that will help us do that. So we're back to radicals at this point. So the first one we're going to use is called the property for the product of radicals. Suppose we have the nth root of a times the nth root of b. We can say that this is the nth root of the product a times b, provided that each of the radicals is defined. That the nth root of a and the nth root of b. By defined, I mean provided that they are real numbers. Okay? So this is nice. If we have a product of the radicals, we can say it's the radical of the product. Or if we have the product, then we can separate that into two radicals of the same index, of the same order. We're also going to use the property of quotients. Keep in mind, this property works only if the index is the same, if the radicals are of the same order. Okay? For this one, if we have the nth root of a divided by the nth root of b, the nth root of a over b, provided again that the nth root of a and the nth root of b are real numbers. And of course, we don't want the denominator to be 0, and so we will say b cannot be equal to 0 because it's in the denominator. Okay? So we can separate the radical of a quotient is the quotient of the radicals, or the radical of the quotient. For example, at the following number. Suppose we have the square root of the number 72. In simplifying this radical, one of the first things that we want to do is to see if we have perfect squares inside the radical. Okay? So we're going to be separating this. And at first you may have a hard time deciding what are perfect squares, but you might come up with this factorization of the number 72, 9 times 8. But we could perfect square 9, another perfect square 4, and then this 2. But because of the property of the product of radicals, we can say this is the same thing as the square root of 9 times the square root of 4 times the square root of 2. Square root of 9, of course, is 3. Square root of 4 is 2. And the square root of 2 can be left inside the radical. So the square root of 72 simplifies to 6 times the square root of 2. In simplifying radicals, we're going to be taking as much as we possibly can to the outside, as many factors from the radical to the outside of the radical. Cubic root, another example. Suppose we have the cubic root of negative 16. Well, as we've seen, you've seen earlier, the negative of the cubic root of 16. So we could take care of that negative by putting it outside, and then we don't have to worry about it. But now we want to, since we're taking cubic roots, we want to break up the number 16 into a product of perfect cubes if we possibly can. And we know that 8 is a perfect cube. So now we're going to say this is minus the cubic root of 8 times the cubic root of 2. And remember that there's only one negative, which is outside the radical. It's sort of like a negative 1. So it doesn't repeat, because then we would end up with something. The cubic root of 8 is 2, and so we have 2 times the cubic root of 2, and don't forget the negative. I've taken every radical. I can't take 2 outside of the radical, so it stays as the cubic root of 2. In an earlier segment, cubes up to a certain point, and this is one of the places where that sort of memorization is going to help a lot, because you're going to be able to tell what number is a perfect square or a perfect cube, as the case may be. Another example. Not know what is the cubic root of 128 or what are perfect cubes in that number, but we can begin breaking up the number 128 into factors. Times 64, in fact. And we're lucky in this case because 64 is a perfect cube. But suppose you hadn't known that it is a perfect cube. So you could have said this is the same thing as 2 times 8 times 8, right? Now, this is the same thing as the cubic root of 2 times the cubic root of 8 times the cubic root of 8. Or we could have said the cubic root of 64, just doing that in one step, if we had noticed that. Cubic root of 2, but the cubic root of 8 is 2, and the cubic root of 8 is 2, so finally we end up with 2 times 2 is 4 times the cubic root of 2. Taking out perfect cubes in this case because we're talking about a cubic root. Now, let's consider what happens when we're working with variables. And so here we have an example of the square root of 50 times x cubed. Variables represent positive numbers. Positive numbers. Okay? So, and we have a square root, so that means that what we want to do is to find perfect squares. So what we'll do is to separate this into a product. That 50 is the same thing as 2 times 25. 25 is a perfect square. X cubed is the same thing as x squared times x. Okay? Of each of these factors inside, but let's skip one step, make it a little bit shorter. For example, we know that we can say this is the square root of 2 times the square root of 25 because each of them are real numbers, and the square root of x squared is x because we're assuming that the variables are positive. Okay, so now 25 and make that a 5 outside the radical. We're going to take the x squared, square root of x squared is x, inside the radical. That's not a perfect square. So it turns out that the square root of 50x cubed is just equal to 5x times the square root of 2x. Again, is there anything else that you can take out? And since we don't know what x stands for, we can't take anything else out. We've taken as much as we possibly can outside the radical. That's the first rule that you should try to remember in simplifying radicals. Take as many factors as possible outside the radical. Okay? First rule. All right, let's continue to look at some more problems.